Hi. Continue curve sketching. This is example 4. Now this function is a little complicated and it's hard to imagine what kind of curve it looks like, right? We know only one thing, that the function is not defined at 0. Because when x equals 0, one of x is not defined. So that's the only big point in this function. Otherwise, the function is defined from minus infinity to positive infinity. The range is also covers all the real numbers. Okay, let's see. Function is not defined as 0. The function is having no y and x intercepts, right? The function has no intercepts, yes, because at 0 is not defined. All right, let's see the derivatives. dy dx. Dy dx. You know that this is by using product, right? This e to the x plus x e to the 1 of x times negative 1 of x squared. And you simplify e to the common, e to 1 of x is common, 1 minus 1 of x. Right? Is that correct? It's correct. So when dy dx equals 0, and means that x equals 1, right? So it means that at x equals 1, the function may reach maximum or minimum. That is a piece of information. When you sketch the curve, we are collecting information. The more pieces of information, for us is better to sketch the curve. And then the second derivative. And save your time, and I just write the result because it's a little complicated. This one is equal to this one is equal to 1 over x cubed e to the 1 over x. Okay. All right, this one will never be 0 because e to 1 over x will never be 0. And this one is not equal to 0. In other words, there's no point to inflection. That's right. So this was not equal to 0. Right? All right, what else we can do? We have only we have only this point. But there's another point it's worth discussing. That is, when the function is not when the derivative is not existing, the curve may reach maximum at minimum. Right? For example, see this point. The derivative does not exist, but it's maximum. So we should discuss those points at which the derivative does not exist. So what are they? What are they in these two derivatives? In this one, x equals 0 is not defined. Here, x equals 0 is not defined. Therefore, x equals 0 is worth discussing. Let me draw the table. So we have two points. One point is 0, right? 0, and the other point is 1. All right, that's it. And then you have a minus infinity to 0, and from 0 to 1, and 1 to infinity. And this is y derivative, second derivative, and this is y. Now, all right, let's discuss this sign. Here, I'm using very large negative number. And here, when x is very large negative number, this is 0, right? Positive. 1 minus that one is positive. That's correct. And this is always a positive, therefore it's positive. At a 0, it's not defined. Here, I'm choosing, say, half. It's 1 minus 1 over half is 2, right? So it's negative. At 1 is 0. This one I choose million. Million is almost 0, therefore positive. And for second derivative, this one, right? When x is a very large negative number, this is negative. This is not defined. Here, I'm choosing, say, half. This is positive. This is positive. Positive. Here, x equal to 0, 1 is positive. X equal to million is positive. Right? Then we have this. This time I have to be careful the way it looks like. This is a bow, right? This is a negative. This is negative, negative, positive. This is the shape. Positive, negative. This is the shape. And positive, positive. This is the shape. Okay. At a 0, it's not defined. At 0 is not defined. But we have to calculate the limit. When x approaches to limit to 0, what happened to the y value? Let's see. The limit x approaches to 0 from, say, left hand side, and y, right? X e to 1 of x. Now, x is a very small negative number, say 0.99999, 0.0000000. Well, negative. Therefore, this one is what? This one is a very small. This is a very small negative number. Therefore, this is a very big negative number. Very big negative. E to the very big negative number is 1 over e to the very big positive number. Therefore, it's almost 0. This one is approaching to 0. This one approaching to 0 when x is a very small negative number. And this one is also approaching to 0, negative number. This is positive 0, this is negative 0. Therefore, the result is a 0, but negative. Which means the y is approaching 0 from below. Well, do you understand? Maybe not. Okay. This is not defined. Function is not defined too. And then other side, when x approaches 0 from the other side, then x to the 1 of x. And this limit is not easy to be found because this is almost 0. This is a very big positive number. Therefore, e to this number will become very large positive number. A small number times a very large number, we don't know. We call it indeterminate form. So we can use L'Hopital rules to find the limit. Well, this is x goes to 0. Or then this is e to the 1 of x and 1 of x, right? By using L'Hopital's rule, and then we can have a limit x goes to 0 by taking derivative both sides. This is e to the x 1 of x squared, right? This one is 1 minus x squared. So you can cancel these two. So this will be what? Infinity, right? Infinity. Because this 1 over 0 is a very big number. Positive. Okay. And for this one, y, when x is equal to 1, this one is equal to 1 times e to the 1, so equal to e. So this is obvious, this is e. And this is the minimum, right? This is the minimum. 0 is the minimum. And then we join these pieces of information together, we can sketch the function nicely. This is the way to sketch the function. This is y, this is 0. And as x approaches to 0 from infinity, negative infinity, it goes this shape, right? It goes this shape. That's right. And at 0 is not defined. At 0 is not defined. Because when x equals 0, y is not defined. Correct? Correct. Now, what is the tangent of this curve near 0? Then you have to take this function, find a limit when x is approaching to 0, almost 0, right? This is this limit, and we calculate this limit is almost 0. Well, you can do it later by using L'Hopital's rule. So this has to be horizontal. Because, how to make this point here? The derivative at 0 is not defined, but close to 0 is 0. Close to 0, the gradient tangent is approaching to 0, so it's approaching to horizontal. And when x is approaching to 0 from right hand side is infinity. So this is the way. When x equal to 1, this is equal to e. This is 1, this is e. This is e. So it goes like this. Then go this way. Yeah. That's a nice function. Alright, so nice graph for this function. Well, hope you like it.